Hello and welcome to the Unit 6 Summative Assessment Study Guide. This is for the interim exam. Let's jump right in. Number 1 says, the table shows the number of cups of coffee Mrs. Johnston drank each day last week. Which day shows the median number of cups of coffee in the table? All right, so they show us each day and the number of cups. So the first thing I am going to do is, in order to find the median, I need to sort these number of cups in order from least to greatest. All right, now that I have these sorted, I am going to eliminate from the outer edges until I get to the center. My median of this data is 3. Which day has 3? Hey, that's on Sunday. Number 2, Frankie wants to have a test average of 91% in math class. His current test grades are 79, 90, 100, and 88. What is the lowest grade he can earn on his next test and still have a 91 average? All right, so this one you have to do a little bit of thinking backwards. So first, I want to go ahead and list out the test scores. So I know I have 79 plus 90 plus 100 plus 88. And then plus whatever the grade is that he's going to get on that last test. All right. So far, I'm going to add these all up together. I know that 79 plus 90 plus 100 plus 88 is 357. So 357 plus whatever grade he gets has to be a certain amount of points in order for a 91% average. Well, you may say, well, how many points do these all have to add up to be? Well, let's see. If I know, and this is working backwards, I know that in order to get a 91% average, whatever my grade was, that final total, right? So I'm going to say the total T, whatever the total is, I have to divide it by 1, 2, 3, 4, 5 scores. So the total amount of points divided by 5 scores will equal 91 in the end. Well, this is just a one-step equation, guys. Circle my variable, ask what's being done to it. That T is being divided by 5. So I'm going to multiply by 5 on both sides. These two 5s cancel out into an invisible 1. So we're left with the total points is equal to 91 times 5. And 91 times 5 is 455. So in order to have an average of 91%, I have to have 455 total points. All right, so 357 plus G, that's whatever grade he gets on that last score, the least grade, that means the smallest grade he could get in order to get a 91, all right? And that will give you a total of 455 points. So we're looking again at a one-step equation. I'm going to circle my variable of G. Ask what's being done to it is being added to 357. So I'm going to subtract 357 from both sides. Over there it cancels out. And over on this side I have 98. G is equal to 98. So the lowest grade he can earn is a 98% grade. Another way you could do this is a guess and check. You can put say a 90, say you start off with a 95. Add those together, divide it by 5. Do you get a 91? No. You'll see that you need to go up higher and higher until you get to a 91. You could have done it that way as well. Number 3, what is the interquartile range in the box and whisker plot below? So the first thing I need to remember is, how do I find the IQR, the interquartile range? Well, the IQR equals taking quartile 3 and subtracting from it quartile 1. All right, quartile 3 minus quartile 1 will give us our interquartile range. So let's look at this box and whisker plot. Remember that this dot here is our minimum. This dot over here will be our maximum, and it doesn't have a dot here, but you know that ending point. This first part of the box is Q1. This line that's in the middle of the box, and it may not be actual middle, but it's in our box as Q2 or the median. And then the last line of the box is our Q3. So our Q3 lines up with 70. And our Q1 lines up with 30. 70 minus 30 equals 40. So that is our IQR. Number 4, Kevin asked some students to shoot 10 paper balls into the trash can. The results of his data collection are below. How many students took a turn taking the shots? All right, so I see the score. So when they threw their 10 into the basket, here are the different scores, all right? And this is the frequency, okay? This is the frequency. So I am going to see how many students got a 5. Well, I see that it went up here to 6. So I'm going to put that info in each bar. Next bar, the students that scored 6, 11 times. All right. How about 7? 7 times. How about that 8 up to 4? And how about that 9 up to 2? And now I'm going to simply add it together. 6 plus 11 plus 7 plus 4 plus 2 equals 30 students. All right. Let's look at number 5. Let's look at number 5. It says the line plot below shows the number of cousins of 16 different students at TAP. Based on the number of cousins, and that's important, based on the number of cousins, which measure of center and variability is the best representation of the data? So the first things first, when we're talking about measures of center, we're talking about mean, median, and mode. When we're talking about variability, we are talking about the range. So they want to know, out of these options, which will be the best representation of the data. All right. So the first things first is to actually calculate these things. So I have the mean, median, mode, and range. And I know the mean. I'm going to add up. I'm going to take all of the data off of here, off of this graph. As a matter of fact, I'll show you how to do that. So I have 11 twice, so 11. And then next I have 3 12s. And then I have 4 13s. 2 14s. 3 15s. 1 16. And I have 1 23. All right. So once I find the mean or the average of this data, I get 13.88. The median of this data is 13. The mode of this data, as I can see from here, is 13. And the range, when I take my max of 23 and I subtract my 11, my range is 12. Now let's talk through a few of these to eliminate them for options. So if we're talking about based on a number of cousins, all right, this is what the number of cousins TAP students have. Each of these dots represents one student, okay? So the range, knowing how spread out the data is, and that's not really going to help me for here understanding anything about the number of cousins that students have. All right. So I'm not going to look at the range here. Let's look at the mode. The mode is not a bad option because the mode is telling us what result repeated the most. So most of these students had 13 cousins. That's pretty cool. So the mode is, that's not a bad option. Let's look at the median. The median is the very middle of the data. So not the highest amount of cousins and not the lowest amount of cousins, but right smack dab in the middle. And then we have the average. The average is 13.88. So that's almost 14. So that's why I'm going to eliminate the mean here because it's almost 14. It's not really a good representation of all of this data. But the median, and it being the same as the mode in this case, is a pretty good indicator of where a lot of the data is. All right, most of the answers were in 13, and 13 is right smack dab in the middle of that data for our median. So I would choose the median here. All right, so let's go ahead and look at number 6. This one was a freestyle question for you. Write a question that is not a statistical question. It is not a statistical question. So let's see. What is Mrs. Johnston's classroom number? This is not statistical, guys. Her classroom number is 505. That's not going to change. There is no variety of data that can come from asking that question. Therefore, it is not statistical. Let's look at number 7. Describe the data on the line plot below. Include information about gaps, outliers, clusters, symmetry, etc. Okay, awesome. So this is actually going to be a little bit of fun for me. So I like to start with, they ask us about gaps. All right, let's look at some gaps. Look at that big gap. Now we have this little tiny ones. This is still kind of clustered, so I'm not going to mess with that. But look at this huge gap here. So we have a gap from 44 to 48. All right. How about an outlier? Yeah, look at most of the data is clustered in this section here. And then look all by itself over here. We have 43 is our outlier. All right, let's look at a cluster. I've brought that up a couple times now. We have a cluster from just say 49 to 54. All right, and let's talk about the general shape. All right, we look at symmetry. Remember, symmetry is where you find the peak. And where's our peak? The highest point here. That's at 53, our peak. And that's when the data falls evenly on both sides. Well, we see that that's not the case. We have a lot of data going in this direction in comparison to the right. We only have this one piece of data on this side of the peak. But over here, we have all of this data. So I see that from the peak, the data is skewed to the left. So the shape, all right, it is skewed left. All right. Number 8, the following table shows the number of miles Miss Tay walked each month in the school year. If she only walked 5 miles in the month of May, what would happen to the mean, median, mode, and range? Oh, this is a good question. Okay, so I want to set this up 2 ways here. I'm going to draw a little squiggly line there. We have our original data, and then we're going to add in May 5 miles. Okay, so I'm going to put the mean, median, mode, and range. So for this original data, just looking at this, our original mean or average is 49.33. Our median is 49. Our mode is 48. And our range is 11. Because that's our 55, our max of 55 minus our minimum of the 44. Okay, so now let's look. If I added in another month here and put 5, for one, notice that only 5 miles in a month, that's way different than the rest of these. So that would definitely be an outlier. I want you to recognize that. Having only 5 miles in the month of May will be an outlier to all of the rest of this data for the months that I did previously. Okay, so let's look at the mean. Now that I'm going to input this in, so I started off with 9 numbers. I'm adding in a 10th for this side. So my mean now is 44.9. Notice that my average decreased. All right, so it decreased. My median is 48.5. That also decreased, only slightly. Our mode didn't change. It's still 48, repeated the most. But our range definitely did change because I went from having, when I looked at the original data, I had a minimum of 44. And now I have a minimum of 5. So now my max of 55 minus my minimum of 5 will give me a range now of 50. So now look, I went from only having my numbers, and this shows that outlier, guys. I went from only having my number spread 11 points across a number line. All right, so from 44 to 55. That's all my numbers spread across. And now I have from 5 all the way to 55. So I go from only having a range or a spread of 11 to going all the way up to a spread or a range of 50. That's a big jump, guys. Okay, so now let's look at number 9. How would you find the interquartile range on a box plot? Okay, so for one, I know that the interquartile range, IQR, equals Q3 minus Q1. Pretty simple, guys. All right, number 10, use the following data to create a box plot and label the following parts: Q1, Q2 / the median, Q3, interquartile range, minimum, and a maximum. All right, so we got some work to do here. So first, I like to go ahead and put my little labels on the side. So minimum, maximum, we have our Q1, Q2, Q3, IQR. All right. So before I can even start this, I need to first go ahead and get my numbers, my data, in order from least to greatest. All right, so I have that data in order, and I can quickly put my minimum is 10. My maximum is 18. So now I'm going to jump to finding my quartile 2. That's my median of all of my data. So I'm going to eliminate from the beginning and ends coming to the center. So my quartile 2 is 14. So this number splits the data in half. So now I'm going to look at these 4 numbers and determine what is my quartile 1. What is the middle of these 2 numbers? So I'm going to eliminate the first and last. And notice I have these 2 numbers. So I want to know what is in between 11 and 12. And when I add 11 and 12 together and divide by 2, I get 11.5. is my quartile 1. So now looking down here at my, so this splits the first half of data. This split all the data in half. And now let's find out quartile 3. So I'm going to eliminate 15 and 18. And then I have two numbers in the center, 17 and 17. My quartile 3 is in between 17 and 17, which means our quartile 3 is indeed 17. All right. So now my IQR is Q3, which is 17, minus Q1, which is 11.5. So that is going to be 5.5. So we got all of that done. Now it's time for us to draw a handy little box and whisker plot. And I am going to cheat a little bit. It's still not going to be perfect, but I am going to cheat and use a quick ruler here. All right. And I am going to, let's see, we need to get some numbers on here. All right. So I didn't have to go too far because I know my minimum is 10. So I'm now going to use my 5-number summary to plot my points for my box and whisker plot. So that is the minimum, put a dot, my maximum, put a dot, my quartile 1 is 11.5, put a dot, quartile 2 is 14, pop a dot there, quartile 3 is 17, pop a dot there. So I should have 1, 2, 3, 4, 5 dots. Now for the ones that are for the quartiles, this is quartile 1, draw a line through it. Quartile 2, draw a line through it. Quartile 3, draw a line through it. And now I'm going to draw a line from that minimum to my quartile 1 and my quartile 3 to my maximum. So I have my whiskers there. And now I am just going to draw across for the bottom of the box and across for the top of the box. So I got a not so perfect but a pretty good box and whisker plot out of this data, okay? And that is what yours should also look like, at least some semblance of it, right? All right, guys, so I think you are ready to go. You're going to do great on this test.